so that everybody else would have this. Okay, good stuff. Okay, so I am going to put up the content. I'm going to put up additional videos for this particular learning unit as well. Just so basically you guys would have the content. The recordings are giving us a huge speech. I'm not sure if your other lecturers have probably told you, but Stream is really not playing ball. So we are having an issue with the permissions and stuff, and hopefully that can be sorted out before the weekend, I'm hoping, but I'll keep you guys in the loop. So today what we're going to talk about is how software evolves. We're going to look at prototyping and incremental delivery as mechanisms to cope with change. And we're going to be comparing two approaches to process improvement. And we're looking at levels in the process maturity model, all pretty theory heavy. And so I'm sure you guys are ready to listen straight after that intense prog lecture that you might have had. The flexibility of software is one of the main reasons why more and more software is being incorporated into large complex systems. Once a decision has been made to manufacture hardware, it is very expensive to make changes to the hardware design. However, changes can be made to the software at any time during or after the system has been released. Even extensive changes are still much cheaper than corresponding changes to system hardware. There are two main ways to cope with change, these being system prototyping and incremental delivery. For system prototyping, it's basically where a version of the system or part of the system is developed quickly to check the customer's requirements and feasibility of the design decisions. This is a method of change anticipation, as it allows users to experiment with the system before delivery and thus refine the requirements. The number of requirements or change proposals made after the delivery is therefore likely to be reduced. In terms of incremental delivery, this is where system increments are delivered to the customer for comment and experimentation. So this avoids premature commitment to requirements for the whole system and allows changes to be incorporated into later increments at a relatively low cost. So your textbook actually talks about these two ways of coping with change. They also talk about two concepts, one being change anticipation and the other one being change tolerance. Change anticipation is building the system so that it can adapt to change easily. And change tolerance is more like you build the system not so much to quickly adapt to change, but it can tolerate the change. It's cheaper to go with change tolerance in many ways. Leaving your code open to change generally can be a little bit problematic in some areas, and you will see this when I show you guys the video at the end. Prototyping is pretty much what we do for the most part with incremental development. You have a small version of the software or some of a part of the software with some functionality. You show the clients say they either like it or they don't. Your WIL project is a little bit like this in the sense that you have several meetings with your client and you show them part of what is being developed. So they're involved within the whole process, if you like. For the requirements engineering process, a prototype can help with the elicitation and validation of system requirements. In the systems design process, a prototype can also be used to explore software solutions in the development of a user interface of the system, which makes total sense because you can give your users a prototype, they can play around with it and report on errors or report on whether they feel like your system is user-friendly. Okay. just a quick one. Am I still with you guys? Because it looked like my Wi-Fi cut off for a second there. Am I still with you guys? Yes,
Yeah,
okay.
all good. No issues.
Okay. Yeah, sorry. My connection just went a little bit crazy for a second, so I thought I actually got cut off. Okay, so in requirements engineering, prototype can help with elicitation. So elicitation basically means gathering. I'm gathering all my results. Um, so gathering results and validating to see if they actually do fit with the system. In system design, a prototype can be used to explore software solutions and in the development of a user interface. Okay, so that's pretty much straightforward. This is a pretty picture talking or just looking at what prototyping looks like in terms of a flow diagram. So establish objectives, define functionality, develop prototype, evaluate. And for all of these, you would have these different sets of documents. So that's basically what this slide is saying. So incremental delivery, as we've discussed before, is an approach to software development where some of the developed increments are delivered to the customer and deployed for use in their working environment. In the incremental delivery process, customers define which of the services are most important and which are least important to them. Again, this is a pretty picture of what this looks like. In fact, this is more like a flow diagram a little bit, if you've noticed. So you define requirements, assign requirements to increments. You design the system architecture, so the architecture being the databases, the interface, the web interface, the app, pretty much the entire thing. Then you're going to develop that particular system increment, validate it, integrate it, validate the whole system to see that it works with said increment. You either then deploy it, or you go back here if it's incomplete and perform these steps again, or you deploy it and maybe your system is then complete. So that's pretty much what incremental delivery would look like. So a few of the advantages of the incremental approach are the following. Customers can use early increments as prototypes to gain experience that informs requirements for later system increments. Also, customers don't have to wait for the entire system to be delivered before they gain value from it. The process also maintains the benefit of incremental development in that it's relatively easy to incorporate changes to the system because you're getting quite a few prototypes of the system before the finalized system is released. As the highest priority services are delivered first and later increments are then integrated, the most important system services receive the most testing. In terms of some of the problems with the incremental approach, one of them is it's problematic when a new system is intended to replace an existing system. Also, most systems require a set of basic facilities that are used by different parts of the system. And also, the essence of iterative processes is that specification is developed in conjunction with software. So unlike the waterfall model where you have your documentation before each phase, you are developing specifications as you are going in terms of the iterative process, which makes it difficult with certain types of software. Process improvement means understanding existing processes and changing these processes to increase the quality of a product or to reduce costs and, of course, development time. So, yeah, if we look back at process improvement, it's improving the processes such that they suit the product or service. So for certain types of system, we are going to use the waterfall approach because that approach works better for that type of system. So in an earlier lecture, I might have said the waterfall approach, or the waterfall model rather, works really well for embedded systems. where you are using hardware, software to control hardware, because hardware is relatively inflexible, and it's better to have loads of documentation when you're doing these types of systems, as generally embedded systems are safety critical systems. So process improvement, also in the types of apps that we all develop in daily life, we would normally use the iterative approach because it gives us that flexibility. Also, if you work in teams, and generally that's pretty much the whole IT industry at the moment, it's all about working in either cross-discipline teams. In other words, there'll be a few people on your team that are not even in IT, but it's because they are particular stakeholders involved in the project that have the knowledge area and the background for that particular business that they might have to guide your project. So even though you are the technical expert, you might not be an accounting expert. You might not be an expert with mathematics. So if you are developing a system for maths or accounting, you're going to have to sit with somebody from that discipline to basically tell you exactly what it is that they want. So yes, in team, as I was saying, I did digress a bit from that point, but in teams, you need informal communication. And informal communication basically works best in the incremental approach. Process maturity, on the other hand, or the process maturity approach, which has focused on improving process and project management and introducing good software engineering practice into an organization, basically means that the level of process maturity reflects the extent to which good technical and management practice have been adopted in organizational software development processes. The primary goals of this approach are improved product quality and process predictability. Process predictability. On the other hand, so Agile, I don't really want to go into too much detail with Agile. We spoke about it in intense detail, especially in SAND. So we know that the Agile approach follows iterative development, and basically they say it reduces the overheads in the software process. Main characteristics of Agile methods are quick delivery, and basically it responds quicker to customers' changing requirements, because if the customer feels the requirements are not really reflected in the first iteration, you go ahead, you can change a few requirements, and it's basically covered in that second iteration, etc., etc. So Agile approach, we all pretty much know how it works. The process maturity approach takes into consideration three aspects, which I'm going to just talk through quickly. So there are three parts for the process maturity approach, these being process measurement, process analysis, and process change. Process measurement basically allows you to measure one or more attributes of the software process or product. These measurements form a baseline that helps you decide if the process improvements have been effective. So as you improve improvements, you remeasure the same attributes, which will hopefully be improved in some way. Process analysis. The process or the current process is assessed, and process weakness and bottlenecks are identified. Process models that describe the process may be developed during this stage. We also have process change, and basically this allows us to change processes which can be proposed. So we're proposing changes to our processes to basically solve some identified process weaknesses. Before I go into the process maturity model, which is another one of those management/IT models, So we talked about the process maturity approach, and basically when we would use this is pretty much if we use any version of the SDLC, be it the waterfall model, be it agile methodology, you still need to measure your processes, analyze them, and work out what to do with change. So the process maturity model is also called the capability maturity model, by the way. So I don't know why they have interchangeable names for basically the same thing. Your textbook refers to it as the process maturity model, even though they caption it capability maturity levels. It is part of the capability maturity model, which is used pretty much extensively, I think, more with software testing. So you can, of course, definitely use it. Well, it is meant for use for the entire business software process, but primarily, just so you know, it is used more in testing than anywhere else. So I'm just going to go through this model with you, all the stages in this model, because yeah, generally a lot of these models are defined by stages. There are 5 levels for the process maturity model. The first one being initial. Initial is where the goals associated with the process area are satisfied, and for all processes, the scope of work to be performed is explicitly set out and communicated to all team members. At the second level, the managed level, goals associated with the process area are met, and organizational policies are in place that define when each process should be used. So there must be documented project plans that define project goals. The next level is the defined level. And this level focuses on organizational standardization and deployment of processes. So basically your implementation of your processes. Each project has a managed process that is adapted to the project requirements from the defined set of organizational processes. In your 4th level, your processes have to be quantitatively managed. And basically this means that it is the organization's responsibility to use statistical and other quantitative methods to control your sub-processes. Optimize, which is level 5, is basically when your organization must use the process and product measurement to drive the improvement of your processes. Trends must be analyzed, and the processes must be adapted to the changing business needs. Now, as I say, it's much easier if you have this model and you apply it to one set of processes in your organization. So as I said, it works very well with testing, and we do primarily use it with testing. So how would we do this? Level 1, initial, we'd build our test cases. We would decide what processes we would employ for unit testing, integration testing, system testing, whatever testing it is that we are going to do. At the managed level, we're going to assign who is going to do what test, who is going to be in charge of approvals for certain tests, which stakeholders would be involved with approving certain tests that you are going to take, who's going to give permissions to use the testing environment. So managed. Defined, you actually are implementing all your test cases, either your unit testing, system testing, customer testing, whatever it is that you are doing in terms of testing would be implemented here. Quantitatively managed, you're going to be using metrics to measure tests and basically see what that outcome is. So how many of your test cases have failed? How many have passed? Your documentation is at every stage of each level as well. You have documentation. The documentation, of course, at all these levels is you are going to be following a specific test plan. So for testing, it's not that hardcore in terms of documentation. Maybe you'd have documentation that within the test plan that the test plan would reference. So the test plan can reference your system specification document or your user requirements documents. But you'd primarily be using your test plan, for example. And optimizing, you'd find a way to optimize and make this process a lot more efficient based on your findings at the other levels. So yeah, as I say, I know this is quite a concept-heavy bit of work in terms of this chapter. So I thought of let's be a little bit informal in terms of everything. And yeah, I'm going to show you guys a video that's basically, it's very interesting actually because it's from a guy who works at Google, and he actually talks about the incremental process. I thought maybe it'll bring it to life a little bit and maybe enhance our understanding in a better way. So let us see.
Hi, my name is Jeremy Walker. I'm a developer advocate at Google, and I'm joined here by Max Alexander. We're finishing our talk on the 3 software flaws in software design. So now you're going to talk a little bit about the method of software design that helps you avoid all of them. Can you give us a little more information?
So I call this system incremental development and design. I used a bunch of English words because I'm generally opposed to buzzwords. And so I just spelled it out as like a bunch of words that actually mean what they mean instead of some word that I invented to sell consulting. Now, before I start into this, let me say that as far as I know, this system works. And it always works as long as you do the actual system and not something else and don't add something to it. If you do this and it doesn't work, then you can email me and tell me. And either I will publish something that fixes what I said, or I will tell you what you did wrong. And my email address is max@codesimplicity.com. So many people have heard about incremental development, where you just write one thing, and then you write another thing on top of that, and then you write another thing on top of that. And many people practice this. What I'm adding to that is incremental development and design, because a lot of what people do is they design something up front, and then they make incremental steps toward it. But what I try to do is I try to rethink my design at every step, at every increment. I rethink my design. And what I say is, every time I want to add something new, the resulting system should look like I designed it from the beginning to do exactly what it does now. This involves a lot of refactoring. So get really good at refactoring. At first, it will be a little slower for you, but over time, it will pick up, and also you will get real good at refactoring. Like I've got really good at refactoring after I started to do this. Like, you can do it real fast, I promise. But it's slow at first, but keep it up. The only important thing is that you need to have a general notion of the order in which you should build things, because if you do things in the wrong sequence, then this system won't work. In general, you want to kind of build from the inside out. So the way that I would think about this is, like, if I was building a YouTube app, the first thing that I would build is the video player, because that's the core of the application. That's the thing that users are actually trying to do. And you can also think of it as what produces a useful product as fast as possible, right? So like the last time I wrote a YouTube app, the first thing I did was I just made a rendering surface that could play a video. And that was it. And it's not a very useful application, but I could have given it to a software developer and said, hey, look, you can change the video ID string in here and you can watch any video that you want. It's kind of useful. It's more useful than if I had implemented, say, the browse interface first. You don't want to be able to browse videos and not watch them. That's not useful.
Right.
But being able to watch them is useful. So you want to find the useful core and write that first. Or the example that I give in the book for ordering is like if you wanted to write a calculator that did simple arithmetic, addition, subtraction, multiplication, and division, you would want to do either addition or subtraction first, probably addition, because it's sort of the base that other things build on, and then subtraction you can implement as a form of addition. And then on top of that, you can implement multiplication, because multiplication is a form of addition, right? And probably subtraction is simpler, so you probably start with that and then do multiplication. And then finally you do division, because division is the operation that depends on all of the other ones. The ordering of the first 2 is not as important, so subtraction and addition, or whether you do subtraction or multiplication first doesn't matter. But you would never, ever want to do division first, because you wouldn't have built up all the correct abstractions or simplicities for addition and subtraction. So let's give an example of this. So let's say that we're going to implement a socket, and we know that we need sort of Unix sockets and UDP sockets and TCP sockets. Okay. So the first step we want to do is we want to write. We just decided to write a Unix socket. We've decided that that's probably the simplest socket that we need, right? And so first we just write a class called socket and then socket test. And this follows all of our previous rules about the implementation of things for the 3 flaws of software design, because you notice there's no generic system here. Like our first step looks like we designed a system that only does Unix sockets. So there's just a class called socket, and then there's a test called socket test. Now we want to add UDP sockets. Don't do this by adding if statements. Don't hack it in. Redesign the system to look like it was originally designed to do exactly these 2 things. So now we create a superclass, an abstract superclass called socket, and then 2 subclasses called Unix socket and UDP socket. And then we create tests for both of those concrete classes. And then we might need a base class for the tests, because they might need to share information between the 2 tests. Or they might need a utility module that has utility functions that they share. But we wouldn't write any of that. We wouldn't write any of that generic bit until we needed it. Now the third step is we need TCP. So now we have 2 kinds of IP sockets. So now we need to abstract out an IP superclass that inherits from the main socket class and then gives us UDP socket and TCP socket. And this system looks exactly like it was designed to do all of these things. And then we also might need to share code between the 2 UDP socket and TCP socket tests for IP-related things. But notice, we didn't pull out IP from TCP until we needed it, right? Now, depending on the specifics of your design, you might have found that it was simple to have an IP class, but I suspect that not. I suspect that like parsing the IP headers and then parsing the TCP headers would actually have been simpler to start off if you were only writing TCP in one class. I don't know for sure, but maybe it would have been. And so that gives us an overview of the system of incremental development and design. I talk a little bit more about it in the book, and I also talk a little bit more about it on my blog.
Great. Well, I had a couple questions I wanted to ask you that you'd given this talk in another environment, and there's some questions that came up there that I thought were great that I thought the audience would love to hear. And the first one is, if your main users are in a certain language, what's the best way to build in internationalization off the bat?
Sure. This question deals with a point that I made earlier in one of our previous talks about that internationalization is something that's really hard to bolt on later.
Yeah.
So you need to sort of know about it in advance, but you don't want to be too generic. You don't want to go beyond your incremental development step, right? And so what you want is some sort of layer or some really simple code that allows you to add internationalization in the future, but doesn't implement it now, right? So for example, if you're using like getText, you have the underscore method that you can surround strings by. So just make sure that every string is surrounded by the right method that would do the translation, because that's really the hard part. The hard part is figuring out the strings, making sure that you're not trying to build sentences out of words, because you can't translate things that way, because you have to translate whole sentences. Just implement good practices at the beginning that have to do with internationalization, but which don't add any significant complexity to your development.
Okay, so adding on to that, you said internationalization is something that's really hard to bolt on later after you've made the app. Could you give a couple items that you've seen in your experience that are just as hard to bolt on later that people should think about ahead of time?
So the first thing that comes to mind is unit tests.
Unit tests. Okay.
That it is really, really hard to add unit tests to a system that was not designed for unit tests. People start off, they think, well, I'll just write some big end-to-end test because my system is really simple and that's all I need to do. But then once your system reaches 50,000 or 100,000 lines and you want to go back and try to unit test all the things, and you've designed them in a way that, like, for example, they're all tied to the database. So Bugzilla was designed this way, where it didn't have any unit tests. And everything was designed as the constructor would load things from the database. And that is really, really hard to test, particularly when the constructor is writing raw SQL. So there's not even like a layer that you can mock out that can like give you the data that you need. And so that is probably the first thing that comes to mind. I'm sure there's other things, but that's sort of like the big one.
Great. So when you train people in these three flaws and how to avoid them, and you go back and look at their code maybe 2 or 3 months later, what was their biggest failing?
That they didn't believe me. And because this is not my opinion. This is not me stating something that like, oh, I think this is what I should do. This is actually the result of a fair bit of research and experience and experiment that I did to develop the laws in the book and these rules. So it's not just me saying like, well, I think you should do this because I'm some sort of authority. Like you don't have to ignore. You can ignore me or not know anything about me, and these should still be true, right?
Yeah.
You don't need to respect me or talk to me or anything. Or hire me to do anything. But people, they weren't strict enough. They thought, well, I can be too generic sometimes, or this is really a situation where I just need to be overly generic, or I'm sure that I can write this code even though I'm only going to need it, I'm just going to need it tomorrow, and I'll just write it now. And they just didn't actually follow the laws or the rules here completely as though they were actual rules.
Great. And the last question we got was around tools to help. I mean, I feel like you kind of explained it with the incremental design, but is there any other tools you suggest using to help you avoid the three flaws?
Yeah, I think having a really strong code review process is really good. Having automated dead code detection can be really helpful, particularly code that's only run by tests, right? So you have code that doesn't actually get used anywhere in your system, even though it gets exercised by tests. Mm-hmm. Which is, by the way, occasionally okay. If the only time that I'm ever like, well, whenever a developer says, no, I'm really going to use this in like 5 minutes. I'm really going to use it in 5 minutes. Like my next change is going to use this code. I say, okay, well, write a test. So that way, at least it's being used by something, so that I can prove that it's actually useful, or I can see an API that makes sense. But I still try to say, like, just wait until normally I would say just wait until you need it in the next time. So I would say code review tools, having a good bug tracker, having a good way to keep track of either cleanup tasks or refactorings that you need to do can really help. But really, code review and the discipline surrounding that is probably the most important tool.
Great. Well, Max, thanks for taking the time to meet.
Okay, guys. Just 9 of you left here, actually. Yes, Charmaine, I will upload the video undone for you guys. Yeah, so a quick one, guys. What did you think of the video?
I thought it was pretty good, actually. It was quite nice to see, like someone that's totally on the other end, or kind of at the finish line, if we could put it like that, talk about it in a real life sort of way, in terms of actually producing the stuff, and him being in the day-to-day and actually having done all the stuff, being able to see how he views it.
Definitely, yeah. No, it's very nice when you pull out people especially people from big companies. I mean, he was working on YouTube, for heaven's sake. So, I mean, yeah. So they actually saying that these abstract models and processes that we learn about is actually things that they do put into practice. And of course, from his perspective, the incremental delivery method does work. Okay. So Raylan was all right. The video was all right, Raylan. Okay. So, in terms of the processes and stuff, yeah, we talked about incremental delivery, the waterfall approach, reuse, which I think we called integration and configuration. All of them, time and place for them, I guess. Every company would implement all these models differently. So whichever company you are joining, you're not going to see the ideal world version of implementation, should I say. Who is this person? Okay, well, they managed to get in somehow. Yes?
What is internationalization?
So basically, okay, Yeah, Americans love this, huh? Making up a word. So internationalization means basically it seemed what they were talking about was for international use. So if you want your website sort of translated into another
Oh,
or adapted to another
yeah,
language,
I
yeah.
thought so.
So
Cool.
that's pretty much what he meant by that.
Thanks, man.
No, you're welcome. So yeah, I'm not going to give you guys a really heavy activity today because I know you guys came back from Prague, and I know Prague is a bit intense this semester. How are you guys finding Prague, by the way, this semester? I know it's just 2 weeks.
It's all right. I feel like the concepts we're learning, although quite high level or advanced, they're really like niche. They're like used in like they'd be used only in like super specific scenarios. Like it's difficult finding like or just seeing blatantly, oh yeah, I can use that here. Oh yeah, I can use that here. Oh, this would make so much more sense if I use this. I feel that
Yeah.
the stuff we're learning really just yeah, you really need a big system with a very specific need to be able to implement some of the stuff.
Yeah, that's true. Are you guys doing events and delegates and stuff, or
Yeah, delegates. We
yeah?
did overloading operators today and indexes. Creating your
Mm-hmm.
own index so you can access like an array using a string or whatever.
Mm-hmm.
And yeah, what else did we do before delegates? That was it, I think.
Okay. So what I think we should do now is I'm just going to show you guys. Actually, let's go. I'm going to go to just an overview of what we are going to look at for wonderful learning unit 3. We've already got there, believe it or not. Um, so we are going to be looking at user and system requirements, functional, non-functional requirements, main activities. Now, this particular set of lectures, very important because it links directly with your guys' POE. But I might not start that necessarily today because I want you guys to reflect a little bit, okay? So let's see how many of you guys are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, great. There's 11 of you here. So I want to actually hear from each of you. If you guys don't want to talk, it's fine. You can type on the side, I guess. I want you guys to reflect, and I want you guys to reflect and tell me what are your strengths in terms of when you develop, and what are your weaknesses? Somebody left. Okay, I didn't think the activity was that bad. Yeah, so you're going to reflect your strengths and your weaknesses, right, in terms of your development. And I'll tell you how this ties in and why it's important. If we know your strengths and your developments, we can link it to what type of modeling and process would suit you. Yeah. It's like a weird personality test. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we've just got 10 of you here, if you guys happily stick around. So should I give you guys 15 minutes and then I can hear from you? Do you guys need that long? 45 minutes? No way.
We can, yeah, just take like 5, 10 minutes.
5, 10 minutes. Okay, cool. So how about this? In 5 minutes, I'll check in with you. In 10 minutes, you guys are going to tell me your strengths in terms of development and what you believe your weaknesses are.
Okay,
Okay, cool.
cool.
Okay, guys, how's it going? When I talk about, by the way, I think Subhashan, development is vague. When I talk about development, I mean, how do you program? Okay, let's go
Yeah,
with
it's
that.
weird because like it's not like what would you consider a characteristic of programming? You know, like
Would you say that you're efficient in terms of your programming? In other words, do you maintain good programming practices or comment on all your code? Do
yeah.
you, what are your weaknesses in terms of, do you have too many lines of code,
Oh,
right,
okay.
for a certain process? Um, so let's see, what else can I think about? Um,
I don't know. Like for me, I don't know. I struggle to plan because we're all still kind of learning and
mm,
anything I'd really like to draw more diagrams before I write code, but
mm, mm,
whatever I draw, I always usually just discard and it becomes irrelevant because it's something better or I
mm,
have a workaround. So at like this point, you know, like planning is like difficult because we're still learning on how to do
mm,
it, you know.
mm, mm,
Um, we don't know all the ways. So when you're at that stage where like that programmer was at, where you kind of know all the ways, now you're kind of just
mm,
seeing, okay, which way is going to work better. You can kind of plan out. But for
mm, mm.
me, who, you know, I don't even know that way X exists, for example.
Yeah,
Now all of a
yeah.
sudden I see it and I'm like, oh, this is going to be work way better. Now I've just null and voided my entire documentation. Do you understand what I'm saying?
Yeah, no, I get you. Yeah. Do you guys think that working in pairs, in if you had to code in pairs, right? It would be a lot easier to code something than just doing it by yourself. So if you were paired with somebody, for example,
I think a maximum of like 3 people.
depends on
Anything
who the
more than
person is.
3. Anything more than 3, I think would be difficult in terms of communication.
Yeah, the communication.
But
That's
yeah, no, I agree with Justine. Very much depends on the person.
depends on who the person is. Raylan saying it will be easier. Well, more hands make lighter work. Yeah, that's true. Okay. Yeah, I guess you can't even really say because you'd assume that everybody that you'd be paired with has the same is at the same level as you are. So you'd probably want to be paired with somebody who thinks very much like you. And that's not always the situation, unfortunately. Okay, so what I am gonna do, we are done with learning unit 2. I want to talk through a little bit of learning unit 3 because I believe that is going to be really useful. So I think we'd go with user and system requirements and we'll touch on functional and non-functional requirements. So user requirements. So user requirements are statements in natural language plus diagrams of what services the system is expected to provide to system users and the constraints under which it must operate. So you're looking at what you want the system to do and basically what load can that system work under, if that makes any degree of sense. User requirements can vary from broad statements of system features to more detailed, precise descriptions of the actual functionality. So here's an example, right? This example is from your textbook. So they talk about this medical care system that deals with patients, doctors, hospital records, all of that. So the MedCare system shall generate monthly management reports showing the cost of drugs prescribed by each clinic during that month. Very nice, very specific. So that's from the user requirement. The user requires these management reports. So that's our user requirement, right? Your system requirement, on the other hand, is more detailed descriptions of the software's functions, services, and constraint. So it's like a user requirement, only it's much more broad, much more detailed. So the system requirements document, sometimes called the functional requirement specification, should define exactly what is going to be implemented. So here's a system requirement example, right? On the last working day of each month, a summary of the drugs prescribed, their cost, and the prescribing clinics shall be generated. Now, how do you know what the difference between a user requirement is and a system requirement? Well, quite simply, a user requirement is a broad statement. A system requirement can be tested. It's quite specific. It's broken up into a few parts as well. So over here, the MentCare system shall generate monthly management reports showing the cost of drugs prescribed by each clinic during that month. Yeah, I suppose in a way you can test it, but it's more broad. If we take a look at this one over here, how do you know that this requirement is successful? You know it's successful if it can be tested. So you can test this. On the last working day of each month, a summary of drugs is prescribed, their cost, and the prescribing clinic shall be generated. So how do you test this? You can wait until the last working day of the month and see if the report is generated. Or you can inject dates into the system to see if the system does do what it's saying that it does. So your system requirements, how do you know they're successful? Can you test them? The system shall generate the report for printing after 5:30 on the last working day of the month. Again, easily testable. You can basically either wait for 5:30 on the last working day of the month to see if it prints, or you can inject dates and see if that works. So these three are your system requirements, and they are your testable requirements. Your user requirements are more broad. System requirements do build from user requirements, though, as you can see. So in terms of our stakeholders, we've got our user requirements, right? And they would be looked at by your by many people. Okay, so your developers would also look at your user requirements. So they're more for your client managers, your end users, client engineers, contract managers, system architects, right? Your system requirements are primarily for your development team. So the only difference really here is system end users and contractor managers are here. They probably your non-IT people. Your system requirements basically are most of your IT people. They've thrown in end users here. I suppose maybe the end users would want to see what these look like as well. So functional, non-functional requirements, man. Do I even need to say what it is, or are you guys absolute masters with this now?
Just keep going. Just keep going. It's fine.
Just keep going? Okay, cool. So functional requirements are statements of services the system should provide, things that the system must do. So in the video that we saw earlier, the guy being interviewed, he was talking about when he was doing YouTube or developing YouTube, he developed the video player first because that would be part of the functional requirements. So your functional requirements, of course, is that your users can watch the videos. So functional requirements, core functionalities. Your non-functional requirements are your constraints on the services or functions offered by the system. So they'd include timing constraints, constraints on the development process, constraints imposed by standards. So they could be your security requirements. As we saw before, usability was part of them as well. In terms of performance and reliability, this would deal with the load on your system. So maybe your non-functional requirement, one of your non-functional requirements could be the system should be available for authorized users 99% of the time. Or it could be something to the effect of, to see how robust the system is, maybe you'd want, in terms of concurrency, more than 300 users, no, let's not use a more than, 300 users can be logged onto the system at the same time, okay? You do get systems, of course, when it comes to X number of users using the system, it crashes, like Takealot on Black Friday. So that would fall into a non-functional requirement category. How many users can basically access the system at the same time without it crashing? So non-functional requirements often apply to the system as a whole rather than your system features. So for example, security would be for the whole of the system. Your authorization, your authentication. Authentication is the right people being able to view the right data, okay? Um, so yes, in terms of non-functional requirements, we've got product requirements, organizational requirements, and external requirements that I'm going to speak to just a little bit. Let me make this bigger for you guys. There are three main types of non-functional requirements. The first one being product requirements, which basically must specify or constrain the runtime behavior of the software. So examples of these would be your performance requirements of how fast the system must be and how much of memory it requires. So your reliability requirements, basically. Your organizational requirements are broad system requirements derived from policies and procedures in the customer's and developers' organization. So examples of this would include how the system will be used, what programming language must be used for the system, the environmental requirements for the system, and so on. External requirements are broad heading, covering all the requirements that are derived from factors external to the system in its development process. So these could include regulatory requirements that set out what must be done for the system to be approved by a regulator, such as a nuclear safety authority, legislative requirements to be followed to ensure that the system operates within the law, as well as ethical requirements. Here are some examples of non-functional requirements. So in your task 1, you have to actually produce a requirement specification document. And these examples will help you in terms of writing your own requirements. So we've got these examples of non-functional requirements under your product requirement category, your organizational requirement category, and your external requirement category. So for your product requirements, the MentCare system shall be available to all clinics during normal working hours. Downtime within normal working hours shall not exceed 5 seconds in any day. So these requirements would fall under your performance and your reliability examples, which we saw last semester. An organizational requirement could be users of the MentCare system shall identify themselves using their health authority identity card. So very similar if we think of Varsity College. When you enter the college, you need to present your student card, or you need to basically present your thumb or your thumbprint to walk into the building. An external requirement is the system shall implement patient privacy provisions as set out in HSTAN 03 2006 Prov. So basically they are going according to a certain privacy provision, probably based on a regulation set out by the government. So it's basically an external requirement, something set out in legislation or an ethical requirement followed by this particular company. So here's quite a nice diagram showing you non-functional requirements and the categories within them. So we talked about product requirements, organizational requirements, and external requirements. And under product requirements, we saw our efficiency, our performance, space. Also, what would be under this is your security, dependability, usability. Basically, everything that was under FERPS last semester. In terms of our organizational requirements, we need to look at the environment, operational requirements, and development requirements. So what programming languages are we using? Where is the system going to be used and by whom would be under environmental factors. external requirements, regulatory requirements, ethical requirements. So is the system working under legislation? Is it legal? Okay, so we've got our legislative requirements, and that some of the requirements under legislative would be safety and accounting requirements as well. So it's quite broad categories if you look at it. And this diagram, I think, will help you differentiate between your non-functional requirements that you can put in your user requirements document or your system requirements specification document, rather. Yeah, so guys, actually, you only need two, okay? Because if I take a look at your guys' POE, so I'm going to look at task 1 again. Oopsie. Okay, so for task 1, software requirement specification document, you need 2 non-functional requirements. You need 10 functional requirements. So if we go back here, we literally need 2 of these, and you can put them in pretty much any category you want. Understandable. But of course, for the case study that you decided to do. So yeah, functional, non-functional requirements. I know it feels like we're doing this every semester because you guys have done it last semester and you're doing it this semester. But yeah, remember, when you are writing out your requirements, especially if it's your functional requirements, you want them to be able to be tested or testable, rather. It just makes it easier for the developer if they see a requirement and it's easy to test. So guys, if you have to tell me what the non-functional requirements would be for your weather app, what would be your non-functional requirements or any non-functional requirement for your weather app? Log in. Okay, yes, perfect. Log in, and that falls under security. Okay, so I know all your interfaces would look very different because you guys would design your interface by yourselves. So remember, usability fell under non-functional requirements. So you can say how easy it is for users to enter their information. Now, of course, I haven't looked at all of your guys' weather apps, but so I'm just pretty much drawing a random one in my brain. So users can use the drop-down buttons to select the cities that they stay in to get their weather. So that would be an example of a non-functional requirement for usability. Can you think of any other ones? I know that the weather system is a small one, guys, but sometimes it's better to suss out requirements for your smaller types of systems. Okay, let's go with an example of a functional requirement for your guys' weather app. Display temperatures for a selected city. Yes. And is that easy to test? Yeah. Capture forecasts. Yeah. So display temperatures for a selected city. Yes. You can select the city and see if the temperatures are displayed for it. Capture forecasts. Yes. Again, Justine, easily testable. Yeah. So you guys get the idea. Okay. So I will put up the video for this at some point when I go through this with group 2, which is probably going to be by Friday. Yeah. So this example here, where these are, I know they're saying system requirements, but really they do overlap. Make sure your requirements are testable. Testable requirements mean that they are more successful. Why? Because if a developer gets functional requirements that they can basically read easily in terms of implementation, it generally is a lot, it goes a lot more smooth in terms of development. Yeah, so your focus is of course going to be more on these type of requirements because of course in your POE, they literally want 10 of these and they want 2 non-functional requirements. So you can pretty much knock this off today. So yeah, they seem to have 100 marks for this specific task. Don't ask me how long it has to be just yet, but I want to go to the rubric over here. So yeah, okay, cool, let's look at this. So you have to have an introduction, and the scores seem to be out of 10 over here. So guys, really nice introduction. So the purpose of the software is well explained. The scope of the project is well described and realistic. That seems to go for another 10 marks. Your functional requirements are up to 20 marks. Okay. The requirements are testable, very important. Okay. The requirements are feasible. My God, there's a lot of categories for this. Guys, you can get really good marks for this by doing a really short document, it seems. The requirements are feasible. The requirements are clear. Guys, there's no reason you should get less than 100% for this task. At least one external system interfaces to the website, and the requirement for interfacing is clearly described. 10 marks there. Okay. And in terms of your non-functional requirements, you just need 2 of them. And basically, at least 2 relevant non-functional requirements are included for 20 marks. Oh my God, guys. No. It's like a 2-page document. What do you guys think of that?
What do you mean it's 2 pages? There's like 10 functional requirements. Using that table that we had, you can maybe fit 2 on, if you want to, do each functional requirement justice, you can, maybe do maybe 3 on a page.
Okay,
Maximum 3 on a page. So that's already 3 pages plus the last one on the last page, plus a page and a bit for your, details and introduction. You can do about half a page of introduction. That's already 10, 11 pages. And then it's your external requirement. That's about a page because you have to describe how your banking system interfaces with that. And then your non-functional requirements too, you can put that on the 3rd page. So we're looking at 13, 14 pages already.
Yeah, with certain people, Emil. Some people will give me some people give me a 2-page document, 10 non-functional requirements, 5 lines for introduction. Yeah, so yeah, guys, make it more involved because it's 100 marks. But yeah, it's just yeah, not difficult to get these 100 marks. I will, as I say, put up these slides, and I will put up the video that talks about these slides until we get the recording sorted out. Are you guys using, any of your other lecturers using Teams, guys, for your lectures?
Cloud. Yeah, just Cloud, I think, yeah.
Okay. Did Bruce say anything about the recordings? Has he managed to give it to you guys? No.
Well, it's the same thing, and we can't watch them either. I don't think anyone's brought it up with him, though.
Okay, yeah. So Serena and Ibrahim, they're working on it. and we're hoping to get clarity by the end of the week. But if there's no clarity by then, I will do the annoying task of downloading them and uploading them to YouTube
Thank you, Zara.
somewhere that you guys can access them, because I can imagine that it is a bit frustrating, especially with load shedding. So yeah. Any questions, guys?
Can you release us?
Was Prague that crazy?
It's been a very lecture-filled day, you know, as every
no,
day.
I understand, especially if you're having a subject after Prague, it is a bit hectic. Okay, guys, everyone good? Anyone else has anything to ask me? Raylan? No? Justine? Justin? Neha? Wishia? I'm just reading you the guys' names right now, though. Sorry, you were sleeping. Ah, Raylan? Okay, guys. I will see you guys next week then. Okay? Everyone good? You guys can go and sleep now. Or better yet, do some of the functional requirements. You're welcome. See you guys next week. Have an awesome weekend. You're welcome.